Hey there, welcome everybody to the Daily Space Weather. We've got geomagnetic unrest conditions continuing here. Lots of aurora showing up around the world. A new sunspot showing up in the southeastern quadrant down here. And lots more to cover here at the Smash News Network, least busted name in news. And congratulations on realizing that the channel exists. This is the last 24 hours from SDO. That's ionized helium, 304 angstroms. Here's the last 24 in ionized iron. As this sunspot sets down here, the likelihood of it producing major flares is very high, and there's also a huge plasma filament, which could lead to a coronal mass ejection right here. You can see that dark absorption feature there. A huge amount of plasma there suspended out there in the solar corona. Here's some composite imagery. This is the 171 plus 211 plus 304 angstroms. And the geomagnetic storm and unrest conditions we're seeing here are caused by protons coming out of this coronal hole at a very high rate of speed, reaching as forecast over 600 kilometers a second. If you want to support the channel via subscription services, become a member of the Smash Team, smashomash.com/Smash Team. As we're made just this side of nothing to put the videos on YouTube, smashomash.com/Smash Team is kind of like Patreon, only with superior capabilities. Join at the gold or silver or bronze level. We do regularly stream live to Twitch, thanks to our new followers over there, twitch.tv/smashomash. Make sure you follow us on Twitter also. A lot of important information showing up there on Twitter, as well as imagery of aurora that we share. So if you don't have a Twitter account, create one. I don't care how pathetic the censorship is on the platform. Create an account anyway, and hold big tech responsible. The markets hold big tech responsible. If you want to hear about that, again, join us at twitter.com. If you want to hold your health responsible, join the American Better Health Organization, otherwise known as SureMed. I'm a member, and I've used the services quite a few times already. The pharmacy discounts, the doctors by phone. There's even virtual veterinarians, although I haven't used that because Smash staff does such a good job taking care of the fish. And happy birthday to Jaws and Phelps, as it is their 8th birthday today for some giant man-eating trained attack fish. You can also get discounts on labs, MRI and CT scans, and there are various different insurances you can also attach to your SureMed membership. You can find links below the video, as well as on the homepage. Today's featured product is Google, as we like to see terms defined on the channel. And one of the terms we like to define is the term Google, which means to use the Google search engine to obtain biased information about someone or something on the World Wide Web. If you're still using it as a verb, you may be interested in the fact that Google is a scam, not a verb. It is not returning objective search results, and you should take the search results on the search engine with a grain of salt. Talk about a monopoly. The first largest search engine in the world is Google. The second largest search engine is YouTube, also powered by Google. So I don't know how that's been working out for you. Have you been receiving biased information by doing web searches and using the term as a verb? Did you know that even Google doesn't want you to use Google as a verb? And of course, today I'm wearing the shirt. So one of the ways that we make Earth not suck again is by holding to account those who are making terrible decisions. Some of the terrible decisions are being made by big tech organizations. Google, Facebook, Apple, and Twitter. The pathetic censorship is not going unnoticed. Markets do not forgive or forget, and markets hold accountable. So that's today's featured product. And happy Labor Day to everybody who's laboring to get people to see your social media posts. Good luck with that, considering the pathetic censorship on big tech platforms. Google, a verb, which means to obtain biased information about someone or something on the World Wide Web. Links below the video to that as well. That's our Red Bubble Shop. It's sorted in order of best selling, and don't forget to enter the promo code NotJust to save 20% store-wide through September 8th. There are our products in order of best selling. Again, click the links below the video to see that. That link also on our homepage at smashandmash.com. And welcome to the Neo Renaissance. And once again, congratulations on realizing the channel exists. It's only the most detailed and comprehensive space weather and imagery of the sun you'll find any place on the internet. If you think there's competition, think again. There's nothing like our channel. So help us out by supporting us via clicks and visiting our links and doing things like joining ShoreMed. And there is still even a Patreon. If you want to hit us up with an instant message, there's a permanent invite to our Discord chat right there on the homepage as well at smashandmash.com. And once again, welcome to the Neo Renaissance. Don't forget to press like and subscribe. Take a moment to do so. Press that share button. Leave us a comment. Tell your friends and foes about the most detailed space weather and the most detailed solar imagery you'll find anywhere on the internet. Visit our playlists as well. There are also videos not about space weather on the channel. Thanks once again to our YouTube subscribers for putting up with the pathetic censorship on this platform. And let's get back to the regularly scheduled content. Volcano rundown includes Kluchovskoy, volcanic ash not identifiable in imagery. Don't assume it's not erupting if you're on the Kamchatka Peninsula. Shivaluch, also not visible on satellite imagery. It's probably erupting as well. Mount Abiko, heading a little farther south to Paramushir Island. 10,000-foot ash plume, flight level 100 from Abiko. Fuego exploding. Now we're in Central America. Guatemala, the location of Fuego, as it explodes there. 16,000-foot ash plume, flight level 160. Headed farther south to South America. We see Nevado del Ruiz exploding in Colombia, producing a 21,000-foot ash plume. Sangay, 20,000-foot ash plume over Ecuador as it explodes. Revenador in that same nation exploding as well. 15,000-foot ash plume, 24,000-foot ash plume from Sabancaya. Please don't pole vault the caldera. It's a flight level 240 over Peru. Some decent-sized earthquakes happening here, a couple over the 6 magnitude range. Largest quake of the past 24 was made in China. Okay, China. This earthquake is a China quake. Probably caused a bunch of landslides and a bunch of damage in places like Kangding. And there's a location of that. It was a 6.6 magnitude quake in this mountainous region here of western China. That 6.6 came in earlier this morning at 4:52 Universal Time. Quite close to the surface, again expected to have caused some damage like landslides and so on. Scrolling up the list here to see multiple 6+ magnitude quakes here over the past 24 hours. Also some quakes there on the west coast of the U.S. So we'll pay slight attention to all of those. So the Southern East Pacific rise also saw a 6.2 that happened just before midnight. 3 minutes before midnight Universal Time, that 6.2 there on the Southeastern Pacific rise, near the Antarctican and Pacific Plate boundaries. Again, there's that 6.6 in China. That one happened at 4:52 Universal Time this morning. And remember, folks, any earthquake can be a foreshock. So 2 6+ magnitude quakes happening there in the past 24 hours. And let's move back to space. So the 10.7 centimeter radial flux now back up to 128 solar flux units. And for you new viewers, the 10.7 centimeter radial flux is a measurement of radial flux density. One solar flux unit is 10,000 joules of radial flux density, and that measurement is proportional to sunspot number. When we see an uptick in sunspots, we see an uptick in radial flux. There's the 1-year chart. The black line is the radial flux. The red line is the sunspot number. And Space Weather Enthusiast Dashboard expecting this geomagnetic storm and unrest condition to calm down here throughout the day today. Maybe a little earlier than expected here. But at the moment, we're down to a KP4 geomagnetic unrest condition. And we're still seeing an elevated solar wind. Also some issues with the electron flux, which we'll get to toward the end of the video. Space weather modeling framework showing a huge reduction in magnetohydrodynamic pressure here, as it looks like the solar wind density has dropped off right there. That's the last 4 hours of Earth's geomagnetic moment from space. The solar wind will show us why it's showing that. Here's Earth's magnetic moment from the ground. And like Earth's magnetic moment from space, that's the last 4 hours. And tons of imagery of aurora on the Twitter page. Again, make sure you follow us over there on Twitter, twitter.com/smashomash. If you're not a Twitter follower, if you don't have a Twitter account, period, get a Twitter account. There's information that we simply will not be sharing anyplace else besides on the platform. And to big tech, we insist that you fix your pathetic software. It is your job, after all. Stop sucking at it. So here is our auroral forecasts. And considering we saw some KP6, there were certainly some great aurorae, especially in places like Greenland. Greenland, one of the best places in the world, that southern tip of Greenland there. Just a spectacular place to see aurorae. And let us know if you saw any aurora in places like Tasmania or New Zealand, if you're viewing the videos from those locations. And if you've got imagery to share with us, send us a message on Twitter, twitter.com/smashomash. You can also put it in our Discord chat. Again, links to all kinds of ways to contact us on the homepage at smashomash.com. So we've gone back to a KP5 here. Geomagnetic storm conditions have returned after seeing a total of 12 hours there of KP6. The planetary K index, a measurement of global geomagnetism, as we're seeing the most significant geomagnetic storm of solar cycle 25. These conditions do cause induction into power systems. We do have empirical data here that we can view as part of the space weather modeling, as part of the Space Weather Prediction Center. Induction into the power grid. The good news about first world countries, folks, is that first world countries have circuitry on their transformers to shut them down if there's too much induction. Power grid failure is much more likely to happen in developing nations than in first world ones, although it is still possible in places like the US. And now we've moved to the real-time solar wind. So the solar wind density has dropped off here, or at least according to the instrumentation that we're using, because that line there at the bottom, that is a switch. You see it's turning from blue to green down here. That is a switch from the Discover to the ACE. So that's probably not a real reduction in solar wind density. It's just a different instrument that switched for whatever reason. We have seen the plasma temperature drop, this bottom line. So that's an indication that the coronal hole high-speed stream is subsiding. Also solar wind speed here dropping down. Current conditions showing up as about 550 kilometers per second, still elevated. And we've just recently switched back to the Discover here. So 550 kilometers per second for the solar wind speed, just under 11 protons per cubic centimeter for the solar wind density. And we still do see a consistent negative BZ signal here. So this top line, that negative BZ signal, the red line there being below the white line in the negative territory, that's the vertical component of the magnetic field. And when we see a strong negative BZ, which is the red line, we see more induction into Earth's magnetosphere, and that makes things like aurorae, induction into power lines, and so on more likely. Field still looking steady here as the coronal hole high-speed stream continues. Goes magnetometers looking very sawtoothed and spiky there over the past couple of days. And that's what you would expect with an ongoing high-speed coronal hole wind stream. Let's take a look at the heliospheric current sheet. It's all North Pole-oriented plasma. There may be a South Pole current sheet headed this way. You can see the South Pole current sheet showing up there in red. North Pole current sheet showing up here in green. Let's take a look at the line of sight plot. As solar cycle 25 progresses. And the source of those high-speed solar protons is that North Pole-oriented coronal hole system. So we've got quite a lot of North Pole magnetism here still in the Earth-facing zone, and quite a lot of North Pole magnetism still at the north heliographic North Pole. So solar cycle 25's got a long way to go. And here's some great imagery from SDO. Those dark regions are areas where there is a very low amount of that species of ionized iron. That's 211 angstroms, part of the ultraviolet, the extreme ultraviolet spectrum. And let's take a look at that a little more close up, as it's such great imagery there of that coronal hole. So there are just protons blasting out of there at a high rate of speed. And let's move to the realm of sunspots, the more commonly understood feature of heliophysics. So we've got a new sunspot right here. This one will be called 3095, right there. And likelihood of large solar flares is actually very, very high as sunspot 3089 is setting. Let's take a look at sunspots from the SDO continuum and magnetograms. There's the SDO continuum. Let's zoom in. And there's that new sunspot group right down there. That's the SDO continuum. Here's the SDO magnetogram. And let's look at flaring. So the flaring profile here is still in the C level of background X-ray output. Don't be surprised to see an M or even an X-class flare come out of sunspot 3089 as it sets on the southwestern limb. Here's one of the best wavelengths to view solar flares, 94 angstroms. Some more active regions here rising in the east, so you can see one down here in the south and one here in the north, not yet visible from Earth. And here's a close-up of sunspot 3089 as it sets. Definitely an area to keep an eye on. As it is by far the most likely place to produce a large flare. We've also pulled that up in 171 angstroms, the house favorite wavelength. As we show the most detailed imagery of the sun on the internet. We haven't seen any spikes in the proton flux here for an extended period of time. If we see a major flare, we might see some relativistic particles. We'll see what happens. At the moment, nothing. And let's talk about cosmic rays real quick. Here's your cosmic ray rundown. We're going to look at about 7 different cosmic ray monitors. And you can see a significant downtick there at Apatity for the past 30 days. Barentsburg, a similar significant downtick over the past 30 days, as one would expect with so much solar activity. Let's go farther south to Greece. Athens, Greece. A downtick there over the past 30 days at Athens, Greece as well. No surprises to our regular viewers, as cosmic ray flux is inversely proportional to solar activity. High solar activity, low cosmic ray flux, and vice versa. Mexico City following suit there with a significant downtick in cosmic ray flux over the past 30 days. And let's go back up north to Oulu, Finland before we go to Antarctica. So there's Oulu, Finland. Significant downtick at Oulu, Finland for the past 30 days. DOMC Antarctica agrees. Significant downtick over the past 30. And DOMB a similar graph, indicating that these are reliable sources for cosmic ray flux. And let's continue on. Now it's time. Time for station identification. Thanks for tuning in to the Smash News Network, least busted name in news. And thanks to everybody who left a comment like Smasho Staff and One Audio. Good morning to you as well. Here's our star chart. And what's going on above our head right now is that Jupiter is setting. Mars is up near the apex of the ecliptic. Venus is also up there, but not visible because the sun has risen over Lehigh Valley, Pennsylvania. As Deneb sets. And let's do a solar system forecast. Here's where planets are now. We've got a gibbous waxing moon. Let's advance the solar system 1 week. Keep in mind, this imagery is not to scale. Here's where things will be in a week. Oh my God, Mercury, the moon, the Earth, and Jupiter will all be in a line, which means absolutely nothing will happen. We will have a gibbous waning moon in 1 week. Let's take a look at some coronagraphs. So here are some coronagraphs. We do have some folks forecasting a coronal mass ejection strike. I think they're looking at a CME that was on the far side of the sun or missing Earth to the south, but we'll see what happens. And I wish those forecasters all the best. That's yesterday's coronagraph imagery. Here's today's coronagraph imagery so far. That's only 16 frames. We're going to show some more here from Stereo A and the Soho Lasco C3. So Stereo A is located at this equilibrium point, Lagrange 5. Soho Lasco C3 located here at this equilibrium point at Lagrange 1, a million miles toward the sun, in between Earth and sun. That's where the Soho Lasco C3 is located. Again, Stereo A located here, trailing the Earth orbitally speaking, seeing space weather ahead of the Earth at Lagrange 5. So it looks like a CME is going to happen here in the earthly zone. That filament can't stay attached like that forever. The likelihood that it will all collapse back down toward the chromosphere is very low. We're going to show you that filament here in a moment in greater detail. But in the past couple of days here, nothing very exciting happening as far as coronal mass ejections at all. Although, again, some are forecasting a CME strike in the next day or two. So here's the last 24 hours, showing the 304 angstroms SDO imagery as well as Lasco C2 and C3. And nothing too exciting happening. Now, keep an eye on this filament down here. It is very huge. And that could eject at any moment. That is a lot of plasma to be hanging out there in the corona. So don't be surprised to see that ejected soon. That's the El Teide hydrogen alpha imagery from the ground-based solar observatory in the Canary Islands, I believe it is. Oh, we've got some more imagery of the closest star for you here. Here's the NASA GOES 16 SUVI for the past about 2.5 hours. That's ionized helium in the great wide field of view. So far, that filament still remaining anchored. Here's a composite showing the HMI continuum, which is like sunspot view, like visible light. 171 angstroms and 211 angstroms. That's the past 24 hours. And what else do we have? bonus features is what else we have. And we've got major charging hazards here, at least surface ones, moving into the Central Pacific there and over Mexico. So don't be surprised to see some issues with satellite communications as electrons of the low energy type build up on the outside of satellites. You see the electron flux here having just risen on both satellites into warning territory. Keep in mind those geosynchronous satellites do measure the electron flux at the F layer of the ionosphere from their geosynchronous orbits using radiography. There's the forecast model, and we're expecting the highest levels we've seen here all year. At least NOAA is in the coming days. And I would tend to agree, following this high-speed coronal hole wind stream. It's the most significant coronal hole wind stream we've seen through cycle 25. And there's a lot of time to go yet, folks. Those coronal holes are probably only less than halfway to what we'd call solar maximum. So here is the one-year chart of the electron flux from Solon.info. And again, they are expecting this to be up here above 1 times 10 to the 9th. So expecting the highest levels that we've seen all year in the electron flux. Let's take a look at the ionosphere, which is full of anomalies. Here's the vibrational frequency of the ionosphere. We've got major low and high frequency anomalies showing up. After that plays through, we'll show you the anomalygram in case you're not familiar with looking at this imagery. So here's the anomalygram showing anomaly in megahertz from the 30-day median. You can see huge swings happening here. Low frequency anomalies, high frequency anomalies. Welcome to September, the most geomagnetically active month of the year. And pay attention to this area right here. That's the South Atlantic anomaly now over the South American continent. That's the weakest point in Earth's magnetosphere. There's another weak point down here by South Africa. And yeah, lots of anomalies there. Some wild swings happening in the ionosphere. And we'll bring up the latest image briefly. There's 12:15 universal time in vibrational frequency in megahertz. And there's the anomalygram for that time, 12:15 universal time. Next, the total electron content forecast, and we're seeing quite constrained electron contents here. Electrons tied into pretty tight regions. So your GPS errors should be fairly localized. It's an orderly total electron content forecast. And if you're not familiar with that, it shows the electrons in between your GPS satellite and your handset. That's about a 12,500 mile distance. And a lot of free electrons will refract that signal. GPS users around the equator are aware of this, that their GPSs will not work around noon. Next, the GO16 SUVI thematic map, showing you all kinds of features there, including prominences, filaments, coronal holes. It doesn't really show sunspots, it just shows bright regions. And since the SDO site's down, it's not slowing us down at all. There's the 195 angstroms wavelength. That's about the last 2.5 hours. And here's 284 angstroms. It's that same period of time, about 2.5 hours. And the places to watch, folks, are Sunspot 3089, this huge filament down here, and again we've got active regions rising in the southeast and the northeast. And now it's time to go to meteorology, as we've got some hurricanes and so on to cover. So let's do it. We'll start out by making the transition from space weather to Earth weather, thusly looking at the auroral ovals, one of the many features of nullschool.net. If you've never checked out the Earth wind maps at nullschool.net, check it out. It's fantastic. There may be some aurora visible there in southern Tasmania. Again, give us a shout out. Drop us a line if you've got any imagery. And by the way, if you are thinking you're seeing aurora, take some video with your camera tripod. Keep in mind, folks, most of the aurora is actually in ultraviolet. So if you think you see the aurora, make sure you take video of it, as much of the wavelength there that is emitted by the atmosphere through the aurora is not visible to the naked eye, but it will be picked up by your camera, so make sure you take video of the aurora. I can't stress it enough. Anyway, there's the likely auroral oval for the aurora australis. Here is the likely auroral oval for the aurora borealis. And still pretty hot there in Alaska for aurora viewing. And next we're going to switch to some wind. There is how the wind blows. And the China coast and Korean coast getting buffeted there, as well as southern Japan by a hurricane. Here are the jet streams. Let's take a brief look at sea surface temperature anomaly here while we're on this side of the planet. And fortunately, the water not anomalously warm there. Although it is kind of warm, so just not anomalously warm. Let's take a look at the jet streams of the west. And there are two significant systems in the Atlantic Ocean at the moment. We'll show those. That's the jet stream scenario. Cold air being injected way down toward Texas. That's central Canadian air showing up all the way down in the Lone Star State. Here are the surface winds. And again, we've got two systems over here, as well as a Pacific hurricane, or a Pacific low off the coast of Mexico there. We're going to show you more in-depth stuff about this and this, the likely storm tracks, and so on. First, the surface winds of the central world. A strong low here south of Africa. You can see that clockwise rotation, the sign of a low pressure system in the southern hemisphere. Here are the jets of the central world. And next, our weather.gov map. If your county is lit, click your county. We've got a lot of flooding stretching all the way from Maine to Alabama. And hot temperatures on the west coast. Again, if your county is lit, head to weather.gov and click your county. Expecting a few inches of rain here in Lehigh Valley, Pennsylvania. Here's your total accumulated precipitation forecast for the lower 48. And let's zoom in a little bit here. It's the same model there, the GFS model for the next 72 hours. Precipitation total shown there in inches. And some areas expecting like 6 inches of rain there. Places like southern Massachusetts. Southern Connecticut, rather. Yowzers. Parts of New Jersey expecting like 4 inches of rain as well. Some serious flooding coming to southern New England and the northern mid-Atlantic states. Next, your precipitation and pressure forecast for the next 72 hours based on the GFS model, showing you the way those tropical lows are going to move. And the pressure is going to drop off for this one, so this is going to intensify here. According to the GFS model, pressure is going to drop down to 957 there. That's significant. So we'll have to keep an eye on that. And another low forming back here as well. And this hurricane here is still expected to continue to the northeast. That's your GFS pressure and precipitation forecast for the next 72 hours. Let's take a look at the satellite imagery. As the sun has risen over those high cloud tops. Just give that a minute to initialize. That's from windy.com, by the way. You can download this mobile app and get that great imagery sent right to your phone. And that is one of the many ways to make Earth not suck again. Impress your friends and foes by knowing the physics and understanding how to forecast the weather. Next year, NASA goes lightning mapper. That's where lightning strikes have been happening, and we've got, oh my God, we've got directed energy weapons again. It's Project Bluebeam, folks. It's Project Bluebeam. Look at this. Oh my God, look at that. It's lightning bolts from space. It's the lightning bolts of the gods coming from man-made things. I'm just kidding, folks. It's because of electrons building up on the outside of satellites. It's lightning on the aperture itself, which looks to the aperture like lightning on the ground, which it isn't. Because that's measuring ultraviolet light, I believe. And let's look at a real-time lightning map to see if there are any terrestrial strikes. Do we have terrestrial lightning in the U.S.? Not so much. Things pretty calm here at the moment. Anyway, if you hear thunder, check out lightningmaps.org. It's highly recommended. Frighten the natives by forecasting thunder. Here's our U.S. Doppler radar map. Yes. Vertical motion of water droplets in the air column. And there are heavy rains coming to the northeast. And we'll also show the shortwave radiation map showing clouds and fog, as we do most days. That's satellite imagery in the 3.9 nanometer bandwidth. Wavelength, I should say. And there is the water vapor map. And quite a lot of dry massive air here in the Atlantic, so that will act as a blocking feature and will not help to strengthen this system. Before we close out, let's take a look at sea surface temperature anomalies in that area. The heck? I just want to look at sea surface temperature anomalies around that area because that will tell us something about how much convection will be available for those systems. And the water is indeed anomalously hot there. So quite a lot of warm water there, but also a bunch of dry massive air. I'm not sure if it's because of Saharan dust. Let's take a look at that too while we're here. And there is a bit of Saharan dust out there. Let's get back to your recap. Once again, there's the U.S. Doppler radar. Shortwave radiation showing clouds and fog. And there's water vapor. And once again, thanks for tuning in to the Smash News Network, least busted name in news. And may that solar wind be at your back.